Industrial maintenance has evolved through 4 generations, each an improvement over the last, yet none sufficient to solve the underlying problem of why machines fail. An excerpt from the upcoming book Rapid AI: Reliability, Availability and Performance Improvement Through Designed AI. From reactive repairs to AI-driven diagnostics, each generation built on the last, but each left a critical gap. Here is the arc of that evolution. Reactive maintenance was the norm for most of the 20th century and remains practiced in plants that cannot afford better, or haven't yet paid the price of catastrophic failure. When a critical pump fails at 2 a.m. on a Saturday, the cascade begins: emergency callouts, overnight parts shipments, improvised repairs, and lingering uncertainty about whether the fix will hold. It is the most expensive strategy per unit of uptime and the most dangerous. Rapid AI rejects the premise that failure is inevitable. The logic seems sound. If a bearing is rated for 20,000 hours, replace it at 18,000. But the landmark 1978 Nowlin and Heap study for United Airlines revealed a fatal flaw. 82% of industrial failure modes follow random or infant mortality patterns. Not the predictable bathtub, where that predictable replacement assumes. Only 5% of failures follow that predictable pattern. A single threshold on overall vibration amplitude can tell you that something is wrong, but not what, why, or how fast it is deteriorating. It generates alarms. It does not generate understanding. Pattern matching AI trains on historical failure data and finds correlations. It can learn that, when feature X rises and feature Y falls, something bad happens, and it scales to large asset fleets without manual watching. Pattern matching AI finds correlation without understanding causation. Without physical understanding, the system cannot distinguish between a dangerous fault pattern and a benign operating condition that happens to look similar statistically. None of them solve the underlying problem: understanding why machines fail and using that understanding to prevent failure permanently. They are progressively better fire departments. Rapid AI aims to be the fire code. The distinction matters because the economics are radically different as you move from reaction to prevention to elimination. Eliminating failure permanently through design out is the highest leverage investment in industrial maintenance. Rapid AI: Reliability, Availability and Performance Improvement by Designed AI rejects the premise that failure is inevitable. Where each prior generation improved the response to failure, Rapid AI addresses its root cause through physics-based diagnostics that see trajectory, not just thresholds, and provide transparent reasoning, not black box alerts.